Hello everyone. Today we discussed about the one more acid-base theory that is called Bronsted-Lowry acid-base theory. So actually, in the name it is Bronsted-Lowry means it's the name of two scientists. Actually, this theory was not given combinedly by these two scientists. Actually, the two scientists are belongs to different countries. They belong to different countries and they given this theory of acid bases independently, but their assumptions are nearly equal. That's why they made it as a one theory. Okay, so Bronsted-Lowry theory. So here it is proposed by Bronsted and Lowry separately, independently. Okay, this theory is the main important points. So we are writing it was proposed by proposed by Bronsted and Lowry independently. There is no combination. There is no combined work is there. So main important thing in this theory is it is totally based on proton. Proton means here proton ela chestamante we discuss the proton which is equal to the H plus. Actually H plus is treated as proton here. So see normal hydrogen manaki what is the configuration 1s1. We know that H11 which is having one proton, one electron, one minus one. There is a no neutrons. No neutrons are present. So then if it becomes H plus, when hydrogen becomes H plus by losing one electron. So after losing one electron it becomes 1s0. Means in one H, the H plus there is one proton is present, there is no electrons, there is no neutrons. Means one proton nothing but equal to H plus, and a H plus can be treated as a proton. Okay, so this theory based on this H plus ion, that's why this theory is also known as Protonic theory. So it is based on H plus, so that is equal to nothing but proton. So therefore it is also known as Protonic theory. Okay, so next, what is an acid? Now we go to the directly the topic. So according to Bronsted-Lowry theory, what is acid, what is base? First see what is acid in terms of this theory is the chemical species which is able to donate H plus. H plus means ఇక్కడ proton term use చేస్తాం. The chemical species which are ready to lose the protons to other acceptors are called acids. Bases means exactly opposite. The chemical species which are ready to accept the H plus or which are ready to gain the H plus ions are called bases. Means acid also and base are both are defined in terms of H plus. ఇదే మనకి అర్హీనస్ థియరీలో acid was explained in terms of H plus, base was explained in terms of OH minus. But here only taking H plus as a criteria, the H plus donor is an acid, H plus acceptor is a base. And we write a simple definition. So according to Bronsted theory, what is an acid? So an acid means the chemical species which can donate are nothing but lose H plus to acceptors. H plus is taken as protons. Okay, the chemical species which can donate or lose H plus ions to acceptors are called acids. Next, what is a base? So what is the base according to this theory? Exactly opposite to the acid's definition. So here we can write the chemical species which can accept, or we can write gain, which can gain H plus ions, nothing but proton from proton donors. They are known as bases. Means simple, in the simple and we can write proton donors or acids, proton acceptors or bases. Okay, now we see. So later we see the examples. Okay, now there is a. It is also explains about the neutralization. So already we know here the comparison between the all theories is very important. So according to the Arrhenius theory, we know that what is the neutralization? So the reaction between acid and base giving salt and water. Acid releases H plus, base releases OH minus. So on their combination formation of water. So this was known as neutralization is according to Arrhenius theory. So but according to Bronsted-Lowry theory, so this is totally different. Here the transfer of H plus ion from acid to base. We know acid means donor of H plus. What is the base? Acceptor of H plus. Means the transfer of H plus from acid to base is treated as neutralization reaction. Okay, so the transfer of proton, okay, from acid to base takes place. Neutralization means transfer of proton from acid to base is treated as a neutralization. So next one more now we write this reaction. So it is also given. So acid base reactions are reversible. So already we know the type of reactions in terms of the direction, that is reversible and irreversible reactions. So according to this theory, all acid base reactions are reversible reactions. So now we see examples for it. So when HCl gas dissolved in water, and there is a formation of an equilibrium, mainly the formation of H3O plus and Cl minus takes place. Here understanding these reactions is very important. See, now first observe the forward reaction. Okay, HCl H2O reacted forming H3O plus and Cl minus. Now we have to identify which in this reaction which species acts as acid and which species acts as a base. See here in the I am writing separately here. In this reaction what happened? The HCl is changed to Cl minus. HCl changed to Cl minus. So how it is possible? HCl changed to Cl minus. Again the same reaction, H2O is changed to H3O plus. H2O changed to H3O plus. So can you guess which acts as the acid, which acts as the base? So HCl, Cl minus and then it is losing H plus. Means simply I am writing as minus H plus. Means HCl loses one H plus ion. Means again to Bronsted-Lowry theory it is an acid. See H2O in this reaction become H3O plus. When it is possible? So by taking an H plus. Means here H2O gains an H plus from HCl. So therefore we can write So with the help of observing this change, we can write HCl is a Bronsted. So actually Bronsted-Lowry acid anali. But simple shortcut lo just we use the Bronsted. Okay. So Bronsted acid also. What is H2O? H2 is a Bronsted base. Like simply take the reverse reaction. Okay. In the reverse reaction, which is formed same the Cl minus it comes. Cl minus in the reverse reaction it changed to HCl. Cl minus formed into HCl. Again the same reverse reaction, HCO plus it changed to H2O. H3O plus changed to H2. Now we can write Cl minus changed to HCl means it takes place by taking one H plus, by accepting H plus. Here H in the reverse reaction H3O plus changed to H2O means losing one H plus. So here we have to observe the main thing, which are act as acids, which are act as base according to Bronsted. See HCl losing H plus, so it is a Bronsted acid. Here again Cl minus, sorry taking not. So see here H3O plus also losing H plus, and here which are losing H plus means which are working as a Bronsted acids. In the forward reaction HCl, in the backward reaction H3O plus or Bronsted acids. Bronsted acids. Next, we can observe H2O accepting H plus, means H2O acts as a base. Here Cl minus also accepting H plus. So we know the acceptor of H plus are treated as a bases. Here H2O and Cl minus are Bronsted bases. Means ikkada ee reaction manam main we can observe different points. First see HCl works as Bronsted acid. So Cl minus acts as Bronsted base. Actually the Cl minus eppadu form ayindi? Cl minus is formed by HCl. HCl enti ikkada what is the nature of HCl ikkada acid. The acid to form in the Cl minus works as a base. See ikkada H2O. H2O takes the H plus ions and act as a base. H2O base laga work chesindi. So ikkada H2O base laga work chesi it is changed to which compound, which substance? H3O plus. Idi H3O plus reverse reaction etla act chesindi? H3O plus acts as a acid. Actually ikkada H3O plus etla form ayindi? From a base. H2O base లాగా యాక్ట్ చేస్తే H2O ప్లస్ ఫామ్ అయింది. మళ్ళీ ఆ H2O ప్లస్ ఎట్లా యాక్ట్ చేస్తుంది? రివర్స్గా యాసిడ్ లాగా యాక్ట్ చేస్తుంది. మీన్స్ హియర్ వీ కెన్ అబ్జర్వ్ మెయిన్ పాయింట్ దట్ యాసిడ్ బేస్ రియాక్షన్స్ ఆర్ ఆల్వేస్ రివర్సిబుల్. Next, in acid base reaction, transfer of H plus takes place from acid to base. That thing. Next, an acid always forms a base. It's a very important point. An acid always forms a base and a base always forms an acid. So like HCl acid, దీంతో ఫామ్ అయిన Cl minus is a base. ఇక్కడ H2O acts as a base, but here H2O తోని ఫామ్ అయిన H3O plus acts as Bronsted acid. Means the main points here we can write. So after seeing one more example, we write the main points. See one more example. When ammonia dissolved in water, there is a formation of ammonium ion and hydroxyl ion. Ammonium and hydroxyl. So compare here, NH3 changed to NH4 plus, H2O changed to OH minus. So can you say NaH3 act as NH3 changed to NH4 plus. When it is possible? NH3. Next, the forward reaction we are discussing, H2O changed to OH minus. So how it's possible? So NH3 become NH4 plus means by gaining H plus. So ఇక్కడ NH3 H plus gain చేసినట్టు we can say NH3 is a Bronsted base. Okay. So ఇది Arrhenius theory లో NH3 basic character was not at all proved. Okay, according to Arrhenius theory, NH3 base కాదు because it does not increases OH minus concentration in the water. But if you follow the Arrhenius theory, NH3 is not a base, but NH3 experiment చేస్తే మనం NH3 base character ఉంటుంది. If you follow the Bronsted theory, it perfectly treated as a base. Okay. So H2O ఇక్కడ OH minus గా convert అయ్యిందంటే when it is possible? By losing H plus. By losing H plus means H2O works as acid. Like see, reverse reaction. The reverse reaction what takes place? OH minus it changed to H2O. In the reverse reaction, OH minus means hydroxyl ion changed to H2O and NH4 plus changed to NH3. Exactly opposite reactions. NH4 plus changes to NH3. Then what changes takes place? OH minus changes to H2O means it is gaining H plus. Means OH minus ion gains H plus, so it works as here it worked as a base accepting of H plus కాబట్టి. NH4 plus losing of H plus to form NH3 కాబట్టి NH4 plus acts as an acid. So ఇక్కడ NH3 works as accepting H plus. OH minus also accepting H plus. NH3 and OH minus are Bronsted bases as they are accepting H plus. Okay. As they accept H plus. Like what about H2O? H2O in the forward reaction loses H plus and NH4 plus in the backward reaction loses H plus. So are Bronsted acids as they donates H plus. Okay, from these and actually main questions ఏంటంటే they give a reaction, we have to identify which works as an acid in the forward reaction, backward reaction, which acts as a base in the forward reaction, backward reaction. Identify is very important. Now, which is losing H plus, which is gaining H plus, we have to identify just by taking the by observing this formula. Okay. Means with the help of after seeing these examples, we can write. We can understand the main points that the very important points. Acid base reactions are reversible. Next, transfer of H plus from acid to base takes place. Next, one more important now we saw NH3 is a base. So NH3 తోని form అయిన NH4 plus ఎట్లా యాక్ట్ చేసింది, యాసిడ్ లాగా వర్క్ చేసింది. In the same way HCl was an acid. HCl యాసిడ్ లాగా వర్క్ చేసింది. సో HCl దేంట్లో ట్రాన్స్ఫర్ అయింది, it is formed to Cl minus. So but acid తో form అయిన Cl minus worked as a base. Means in acid base reaction, acids always form a base and bases always form an acid. Here one more very important thing is, so for example, HCl, we know that HCl is a strong acid. Okay, so in strong acid to మనకి ఏం ఫామ్ అయింది, it loses H plus ions, it acts as acid. దీంతో ఫామ్ అయిన Cl minus ఎట్లా వర్క్ చేస్తుంది, సో an acid always forms base only, so Cl minus base లాగా వర్క్ చేస్తుంది. So in this theory one more information is given that an acid forms base, a base also forms acid, but their nature, not only their nature is different, their strength is also different. Nature different అంటే acid base form చేస్తుంది, base acid form చేస్తుంది, అది nature different. What is the strength లో difference అంటే, ఇప్పుడు HCl we know that is strong acid, సో ఆటోమేటిక్గా Cl మైనస్ ఏంటిది బేస్ ఫామ్ అవుతుంది. అయితే what is the nature and strength? నేచర్ అయితేనేమో బేసిక్ నేచర్, స్ట్రెంగ్త్ ఏమో వీక్ అవుతుంది. అంటే స్ట్రాంగ్ యాసిడ్ ఆల్వేస్ ఫార్మ్స్ ఏ వీక్ బేస్. ఫర్ ఎగ్జాంపుల్ here NH3 is a strong base, NH3 strong base, it forms by taking H plus, it takes NH4 plus, so NH4 plus is a weak acid, means acid forms base forms acid, stronger forms weaker, weaker forms strong. Okay, means strength lo opposite, nature lo kuda opposite. Okay, here strong acids always form weak bases, and the weak acids always form strong bases. So for example, if you see acetic acid, so acetic acid is weak acid, acetic acid treated as a weak acid, so దీంతో ఫామ్ అయ్యే acetate ion, acetates known as acetate, by losing one H plus ion, the formed ion is called acetate. Acetate is a base, but it is a strong base. Okay, so only a HCl example would have them, you have to write it also. H plus is a strong acid, we know that it is a strong acid, and the formed Cl minus works as a weak base. Okay, next we can write some more points. So same, a strong base always forms weak acids, and weak bases always form strong acids. Means the totally reciprocal, nature also reciprocal, strength also reciprocal. Okay, so next so one more important concept in this theory is conjugated system, or nothing but conjugate acid base pair. So very important. So conjugate acid base pair. So conjugate means it is a couple, it's a couple of chemical species, it's a couple of chemical species which are differ by one proton difference in two chemical species name antamante, they treated as a conjugated acid base pair antam. Okay, this is exactly introduced in only this theory. Okay, so already we know some examples, already we done HCl H plus, sorry, HCl and Cl minus. Then what is the difference in the HCl and Cl? If HCl loses one H plus, Cl minus forms, and if Cl minus gains one H plus, formation of HCl takes place. But HCl ki Cl minus ki what is the difference? One H plus means one proton is different. I mean HCl Cl minus ee couple name antamante, it's called conjugate acid and base pair antam. Okay, for example, if you take H2SO4. H2SO4 if loses one H plus, actually H2SO4 is ready to lose two H plus ions. We know it is in the basicity acidity concepts. Acids kada mana basicity concept cheptam. According to basicity concept entry, the number of H plus ions can be released from an acid is called its basicity. So ఇక్కడ H2SO4 కి 1 H plus lose అవ్వచ్చు, 2 H plus lose అవ్వచ్చు based on the reaction. Okay, based on the conditions. If H2SO4 by losing 1 H plus, it becomes HSO4 minus. But what is the H2SO4 HSO4 combination? What is the difference? Just 1 H plus is different. H2SO4 by losing 1 H plus it becomes HSO4 minus, and HSO4 minus by gaining 1 H plus it becomes H2SO4. Okay, for example again I am writing H2O. If H2O loses 1 H plus, it becomes OH minus. If OH minus gains 1 H plus, so it becomes Bronsted, it's acid. So it's acid. Okay, means so the afterwards we read the many examples. Main examples are very important here. Okay, we can define that the couple of chemical species which are defined by one proton are called conjugate acid base pair. So simply I am writing, so conjugate acid base pair means the pair of chemical species or substance differ by one proton. So, or is called acid conjugate acid base pair. So here important how to write the conjugate acid base pair. Okay, so for example HCl ki acid చూస్తే అది acid then conjugate base ఏంటిది Cl minus. The base రావాలంటే we have to remove the H plus from that acid. Okay, just for example HNO3, we know that it is an acid. So what is conjugate base? Just NO3 minus. Mean HNO3 ki NO3 minus ki nitrate ion ki what is the difference? Just only 1 H plus ion. If HNO3 loses 1 H plus, it becomes NO3 minus. If NO3 minus loses 1 H plus, sorry, gains 1 H plus, it becomes HNO3. So what is the difference? The difference was 1 H and 1 H plus, so it is a conjugate acid base pair. So ikkada so HNO3 ఇప్పుడు acid, so దీని base రాయాలంటే we have to remove H plus. అంటే ఒక X species కి ఏదో X species కి మనం దానికి కాంజుగేట్ బేస్ రాయాలంటే we have to remove H plus. ఇప్పుడు NO3 minus is a base. ఇప్పుడు NO3 minus కి మనం దాని కాంజుగేట్ యాసిడ్ రాయాలంటే 1 H plus యాడ్ చేయాలి. ఓకే, రిటర్న్ లో 1 H plus means why we are taking example is to write a general sentence that so we can write a sentence that is very important. So conjugate acid of, first we write about the base. Okay, conjugate base of a chemical species, say X. So X కి మనకి కాంజుగేట్ బేస్ అవసరం. సో కాంజుగేట్ బేస్ రావాలంటే జస్ట్ రిమూవ్ ద H ప్లస్. ఇప్పుడు మన HCl కి కాంజుగేట్ బేస్ Cl minus means just write as a general formula X minus H plus. X we are taking a general species. The same way conjugate acid of X. Just remember for a same general ఇక్కడ మనం X compound X అనేది general గా తీసుకున్నాం, but in some compounds they are ready to accept the H plus, they are ready to donate the H plus also. But whatever it is, if the question is write the acid for a species రాయాలంటే దానికి H plus యాడ్ చేయాలి. బేస్ ఫర్ ఏ స్పీసీస్ రాయాలంటే we have to remove the H plus. conjugate acid of a substance X is, that is X plus H plus. So these two are taken as formulas. Okay. So conjugate base. So base of X reactant, they will have to remove the minus, we have to remove the H plus. So acid of a species reactant, we have to add the H plus. So now we see some examples of it. Next, one more important in this conjugate acid base pair is if. Already in acid base reaction we discussed. If conjugate acid, for example CH3COH is an acid antam. So acid to form what is the conjugate? This is say conjugate acid. What is conjugate base for it? What is conjugate for this conjugate base for this acid? Base level to have to remove H plus. So minus H plus and I take CH3CO minus. So it is a strong acid. It works as a strong acid. It is a strong base. So it is a weak acid. Means in a conjugate acid base pair, if acid is a weak, base will be strong. If acid is a strong, base will be weak. Means in the strength they are different, exactly reciprocal. So there is a many number of examples and the list is there. Tomorrow we discuss the list. Okay.